Hi friends, today we are going to learn how to use oscilloscope and how to test a motherboard by oscilloscope. We'll see today. So this is a digital storage oscilloscope. I turn on the scope. And this green line is called the cursor, and we kept oscilloscope on 1 volt. This is called the probe. This is the negatives. We have to connect at ground, and this portion we have to check the signal. This knob is for voltage. This knob is for voltage, and this is for the position. This is for the brightness, and this is a dual channel oscilloscope. Channel 1 is this, channel 2 is this. This for the frequency, and now we kept on 1 volt. These are the screen grid where we can check all the voltages as well as frequencies and the signals. It will come analog forms here, and it will show on digital format here. Now we'll check a test point. This is for the test point to check whether the oscilloscope is working or not. This is a test probe. It sends out 1 kilohertz frequency. We'll check now. We have to connect the same probe here. One is ground and another is a frequency, that is 1 kilohertz, and it will show on the screen like this. Like this. So this frequency is showing 1 kilohertz. Showing 1 kilohertz, and the time is approximately in millisecond, that is approximately 1 millisecond, and voltage is 3 volt, that is we kept on 1 volt, and this my cursor is here. Just remove this. My cursor is here, that means this is my 0 volt, and when I connect this probe here, at that time my cursor goes here. You can see that means 1 volt, 2 volt and 3 volt. This is 3 volt, and this is a square wave frequency, and this frequency is approximately 1 kilohertz. Okay, so in this way we have to check. Now we'll check actual motherboard by using oscilloscope. We'll check all the signal like clocks and all frequencies and bias signals and frame signals. We can check all the signal by using oscilloscope. So your motherboard connected to the DC power supply showing 18 milliampere, and this one is a PCH chips, and we can see there is one crystal. This crystal is 32.7 kilohertz frequency, and this crystal is called the RTC crystal also. And first we'll check that crystal. For that we have to keep voltage at approximately 100 millivolt. now kept at 100 millivolt. Channel 1 is 100 millivolt, and I'm going to test crystal, RTC crystal, which is connected to the PCH, and for that I have to do a little more changes on the probe also. This probe have a one function that is called 1x and 10x. I have to keep at 10x, and we'll check the crystal now. First we have to connect a ground, connect from ground and another point to the crystal like this. See, it's showing the frequency, that is a 32.7 kilohertz. If I decrease the voltage, and I have to tune frequency, so it is 32.7 kilohertz. There is another switch, it's called the auto switch here. You can use that switch also. Once you connect the auto, it will show everything automatically like this. I'll press auto. See, it's showing all the parameters like peak to peak voltage, time and frequency. So like this. So this RTC section is working now, and the PCH part is working. Now we'll check the next section. We'll turn on the laptop and we'll check rest of the signal. Now we'll turn on the laptop. It's showing 10 milliampere. I turn on the laptop and the current is showing somewhere around 900 milliampere. And the next thing we are going to check, that is whether my motherboard accessing bias or not. We'll check on the bias pin number 1 and 2. My bias is here on the back side. So this one is my bias. The bias numbers start from 2.5 and it's little bit bigger than the mouse spec. So bias pin number 1 is a chip select and pin number 2 is a read. So I'll check that. But before that I have to turn off the laptop and I'll turn on again. I'll keep setting on 1 volt. I'll put it on set as a default and measure, so it's now normal setting. Okay, and we'll check the bias setting, bias pin now. So this is pin number 1 and the next is pin number 2. We're going to check now. Okay, so we are now checking PCH. We kept our probe at bias pin number 1, that is a chip select. When I press the power button, some signal should come out on the screen, and if the signals are coming, that means the PCH is probably working and it's accessing the bias. You can see, we turn on the laptop. See, the signals are coming. and this accessing is coming. That means the PCH is accessing the bias. So if it is not comes out, if it is a flat, it's not responding anything, that means there are 2-3 possibilities. Possibilities number one, the clock is not functioning, or PCH not working. It's like that. So the signal should appear on the screen. So next we'll check clock signal. There is another crystal at PCH, that is a 25 megahertz. That is a clock chip. The clock, it generates a clock frequency. We'll check now. But again, for that we have to keep our oscilloscope at 100 millivolt and into 10x. So we again change the setting to the 100 millivolt. See, now it's at 100 millivolts, and we kept our probe at into 10x, so it is into 10x. Now we'll check another crystal. This 25 megahertz crystal is located here, so we'll check that crystal. Now we'll check crystal. Everything is ready. Laptop is now off condition. Turn on the laptop. See, it is showing a 25 megahertz. So this 25 megahertz showing means the crystal is working, and the clock section is also working. The next clock, this clock, basically the crystal is a clock input. It generates a different frequencies inside the PCH, and it send out to the CPU, send out to the SIO, to RAM, like that. So the next is we are going to check a clock frequency that is coming on the SIO. That is a 33 megahertz. It's called the LPC clock. NPC 795P, and we have to check the data sheets, the pinout configuration for this SIO. So here is a data sheet for this laptop, and I taken out SIO pinout, and we have to check clock and frame signal. So the clock is pin number 2 and frame is pin number 3, so we have to check pin number 2 and 3. If pin number 2, we should get 33 megahertz, that is a clock frequency, and if that is coming, that means my clock section is okay. And at pin number 3, we have to check a frame signal, and if this frame signals are coming, that means CPU is accessing the data bus. So it's like that, so we have to check that. So connect at pin number 2 and turn on the laptop. See, this clock is coming. We can check by pressing the auto key also. It's 33 megahertz coming. That means the clock department is okay. The next signal we are going to check, that is the frame, that is we are going to check on SIO pin number 3. Now we'll check the frame signal at pin number 3, the SIO, and when I turn on the laptop, it will show some signal. See, signals are coming. These signals are called the frame signal. Okay, we'll see once again. Let's check once again. You can see some pulses comes and gone, and this signal is supposed to come, and if these signals are coming, that means CPU is accessing the bias. Okay, so the next signal we'll check, that is called the SM bus. When PCH doing the post, it's called the power on self test. He's accessing the BIOS. At that time he read the RAM, that we call the SPD, and that signal we are going to check. For that we are going to use a RAM card tester. So this is a RAM card tester. So we have to use at RAM socket, and we can check the different signal at here. So it's very easy to diagnose the laptop. Here are some, we can check all three voltages like VDD, SPD and VTT voltage. We can check the VDD voltage at this point. Here we should get 1.5 volt if it is DDR3, and if it is DDR3 I will get a 1.35 volt. Then beside that there is one pin, it's called the VTT pin. Will get half voltage of the VDD. Here will you get the voltage, and next is the SPD voltage. This point is called the SPD voltages. Here we'll get a 3.3 volt SPD voltage, and the next is a reset signal, which is very important signal. It's called the reset signal. When PLT reset is generated by the PCH, after that CPU generate a DRAM reset, and he reset the RAM. That signal we can check here. Okay, this is called DRAM reset. And the next signal we can check clock at here, and the next signal is SPD read and write. When PCH access the RAM, at that time he communicate with the RAM via SM bus. SM bus is a two-wire communication protocol. System bus and system clock and system data. So we can check this communication at this 2 point. This 2 point we can check. Okay, so all this signal we are going to check now on the oscilloscope. Okay, for that first we have to connect this RAM socket tester at RAM socket like this. Okay, now it's ready to work. So first we'll check all the voltages by using oscilloscope like a VDD, VTT and SPD. All the pins I already shown you, that is here, and we are going to check all the signal by using oscilloscope. So we'll first check VDD voltage, then VTT and SPD. I kept oscilloscope at channel 1 on 1 volt, and I turn on the laptop. Laptop is on, and we'll check this voltages. First we'll check a VDD voltage. VDD voltage, this is supposed to come 1.5 volt. You can see it's showing a 1.5 volt here. This is 1.5 volt. This is called the VDD voltage. The next is VTT voltage. The VTT voltage almost half to the VDD. It's showing it will show 0.75 volt. You can see on the scope it's showing the voltage 0.75 volt, and the last is SPD voltage, that is it will come 3 volt. It goes 3, it's showing 3.3 volt. You can see here, like a multimeter, it's showing a 3.3 volt. You can no need to use a multimeter. You can check by oscilloscope also. It's showing a 3 volt here. That is a. So in this way, you can check all the signals and all the voltage at this RAM socket tester. like you can check all the voltages, whether it is coming to the RAM. You can check the connector is working or not, like that. And the next we are going to check rest of the signal, like DRAM reset, and we are going to check this SM bus. The DRAM reset is a very important signal. When PCH generate a PLT reset, at that PLT reset reset the CPU. This is called the CPU reset, and after CPU reset the CPU generate a DRAM reset and access the BIOS, access the RAM. So this DRAM reset is coming on pin number 30 on the RAM slot, that we can check. This is here. It's very easy to locate. So it will come 1.5 volt. You can see it's showing 1.5 volt. It's coming 1.5 volt. Remove the probe, it goes 0. Connect the probe. See, it's coming 1.5 volt. This DRAM reset is very important signal. Without this signal, display can't come. So it's a very important signal. So in this way we can check the DRAM reset. Now the DRAM reset means the CPU is ready to work, and the next is generate a post. CPU access the BIOS and he do the post, that is called a power on self test, and he check the RAM capacity of the RAM via a SM bus. SM bus is connected to the PCH, is a two-wire communication protocol, and we'll check now SM bus. We'll check next signal is called the SM bus. Turn on the laptop. It will show pulses. You can see. You can see such types of pulses should be appear on the screen. There is a two-wire SM bus communication, clock and data. If this signals are coming, that means the CPU access the RAM and the post is going on. So it's like that. So in this way we have to check all the signal by using oscilloscope. Thank you very much.